Hello, everyone. So these are going to be your Module 9 Play Posit videos, and I'm sorry again that I was so late in putting these together. However, there's some good news. So this week, we are going to be talking about rational functions, and at face value, there's a lot of new material that we need to go over. However, because we talked about polynomials just last week, you're going to see that there's a lot of stuff that we can just kind of use what we learned about polynomials and then tweak it just a little bit to fit these rational functions. So right away, one of the first things we can do is we can even define rational functions using the idea of polynomials. If we understand what a polynomial is, that we have some terms like, you know, I'm going to use some subscripts here. Don't worry about it. But right, polynomials have some terms that look like this. And then if we just allow to have a fraction now, and the numerator is a polynomial, and the denominator is another polynomial, then this is a rational function. A rational function is simply a fraction of two polynomials. So another way you could say it is if p of x is a polynomial, and q of x is a polynomial, this just means, repeat the same, is a polynomial, then a rational function would be p of x over q of x, just dividing those two polynomials. So in a little bit, when we start talking about these functions, everything is going to come down to sort of the same things we talked about with polynomials. Can we factor them? Can we find the zeros and all of this stuff? But we're just going to be looking at the zeros in the denominator as well as the numerator and seeing how those interact. But before we can get into talking about that, we need to talk about, just some rules about simplifying, rational expressions. Um, so for example, when we look at these rational expressions, are you tempted to cancel anything? Right. Maybe you're tempted to cancel these y squareds, but this is something I've tried to make a really clear to y'all throughout the semester that we actually can't do that. And there's actually a reason. It's because these y squareds are both tied via addition to some other terms. In particular, there's a term that doesn't have any y's in it. So just because this term has y squared doesn't mean that it can cancel, for example, with this term or this term with only one y. So because these are connected in that way, they can't cancel yet. When these polynomials are in the general form or the standard form, it's going to be a lot harder to find things to cancel. However, what if we were able to factor each of these polynomials? So we can see both of these polynomials have a leading coefficient of 1. So factoring them is just saying what are two numbers that multiply to, for example, 25 and add to 10? And those numbers are 5 times 5. So I can factor the numerator into y plus 5 times y plus 5. The denominator, similar situation, but this one factors into y plus 5 times y plus 6. 6 and 5 multiply to 30 and add to 11. So as you can see, once again, we're in another unit where factoring is very important. If factoring is easy for you, then you're going to jump straight to this step pretty much, without too much work. But if factoring is still a challenge, then this is going to become the hard part of the problem. So you're going to have to kind of assess if you want to go back and study more factoring. Remember, there's factoring materials on Blackboard to study. For these videos, for the sake of time, I'm not going to spend too long on the factoring. What you're going to see is the amount of time it takes me to do these factorings when I'm using the strategies that are taught in class. So for these ones where there's just no leading term or the leading coefficient is just 1, then factoring was pretty quick. And now we can see these factors are no longer separated by plus and minus. They are separated by multiplying. And that means if one factor on the numerator is the same as one on the denominator, they can truly cancel and we can simplify this function. All right, let's do the process again. This time, I notice my a values of the quadratic, right? The leading term coefficient, those are not 1 anymore. So I am going to do really quickly the AC method here. Because I told y'all this is legitimately, for me, the fastest way to factor. Even though it has more steps than some of the other methods, I find that I can do this much faster than I can guess and check. So I want two numbers that multiply to not 4, but the product, which is -8. And then they still have to add to the middle term, which is 7. And then it looks pretty good from here to do 8 and -1. Now, we don't get off so easy as before. We have to actually rewrite the original with plus 8x and minus x. Then we have to factor by grouping here. So from here, I can pull out a 2x. And from here, if I pull out a -1, I can see that I get x plus 4 again. And then I can pull that out, and I leave behind 2x minus 1. And again, that method is called the AC method, and I go over it in my factoring video that's posted under the module 0 course content. Let's factor the other one really quick. So let me clear this out. So as you can see, for these problems, when it says simplify the rational expression, your brain should really jump to factor the numerator and denominator. Again, here, we've got 4 times -2. It's going to give us the same product. So again, I want to multiply to -8, but this time I've got to add to +2. So I'm thinking 4 and 2 in some combination. And since the 2 needs to be positive in the end when we're adding, that means 4 needs to be the positive one. So again, I almost just skipped ahead, but we actually got to write this out now. Or -2, sorry. And then factor by grouping. And so this one factors into x plus 1 times 4x minus 2. Now hang on. None of my factors in the numerator and denominator look the same yet. But is there something that I could factor out of one of these factors? X and 4 have nothing in common. 2 and 1 have nothing in common. 1 and 1, nothing really to do there. But 4 and 2, those both share a 2. So if you look, I can actually factor a 2 out of that binomial like this. But when I factor the 2 out, it's not going to be 4x minus 2 anymore. It's going to be 2x minus 1. And then we see these can cancel. So finally, I might simplify my answer like this. Just pulling the 2 out to the front, not because it's necessary, but because it's a little easier to look at.